So far we have learned about quadratic functions, linear functions, and hyperbolic functions. And today's lesson we will learn about exponential function. And today's lesson will be an introduction, that is, it will be very basic, and anyone from grade 10, 12 will be able to grasp the concept that will be introduced today. Let's get started. An example of an exponential function is given by y is equal to 2x. It can be any number. Mind you, before we even get started to explain an exponential function, why is it an exponential function? Note that this is not the same as y equal to x squared. This is a quadratic function. From the previous video, we explain what a quadratic function is. The reason why these are not the same, the difference is that look at the base for the exponential function. The base is a number, and with the quadratic function, that base there is x. Now that you understand that an exponential function is different from a quadratic function by the bases and how it grows. So we will start with an example, which is what I have given you, y is equal to 2 to the power x. We will start with an example and try to draw that. And from there, we will have rules of an exponential function. Because if you have seen an exponential function, is always given with some rules on the side, and we will get to see why that is the case. But let's start and draw y is equal to 2x. So we will have x and y values. So we will have let's start with the positive numbers. So we will start with x is equal to 0, and when x is equal to 0, that is, we have 2 to the power 0, that is equal to 1. Any number to the power 0 is equal to 1. Why? That is because you can take this as a quotient rule from the exponents rule. So why do we have 2 to the power 0 here? Let's start with that first. So any number to the power 0 can be represented as, for example, let's say this is 2 to the power n, n meaning any number, divided by 2 to the power n, right? So this is the same as 2 to the power n minus n, which is the quotient rule. Note that n minus n is equal to 0. So that is 2 to the power 0. And this can be divided, and that will give you 1. So that's why any number to the power 0 is equal to 1. Let's move on. And then when x is equal to 1, it will still be the same number. So 2 to the power 1 will give you 2. And then when x is equal to 2 will give you 4. And then when x is equal to 3 will give you 9. And then when x is equal to 4, it will give you 16. And then when x is equal to 5, it will give you 25, and so on. As you can see here, we started from 0. Let's see when x is negative. So we will have now minus 1. Do that again. Y is equal to 2 to the power minus 1. Any number to the negative number, you can represent it like that. You see? So that will give you 1 over 2, which will give you 0.5. So this will be 0.5. And then you do the same for y is equal to 2 to the power negative 2. And that will give you 1 to the power 2 to the power 2, which is a quarter. Let's see when it becomes bigger. So you have y is equal to 2 to the power negative 100 or 1000 and so on. So this will be 2 to the power 1000. So you see that you are dividing with a bigger number. As it gets bigger, the y value will be very, very small. So it will be approximately 0, but this is not equal to 0, right? So because that is the case, you can see that as the more you get bigger, you are getting close to 0. And y will never touch 0. You will always approximate to 0, but you will never touch 0. So with an exponent, you can never have y to be 0. So we're going to try and draw this function. So let's try and remember some of the values. We know when x is 0, that number is a given. I am saying that now. I've told you why that is the case, that any number to the power 0 is equal to 1. And you know what happens when x is 0? You get your y-intercept. So you have your y-intercept. So your exponent is going to cross there. As the values of x are increasing, y is increasing. But note that the way that y is increasing is big. You can see x is increasing in the increments of 1, but with y, you see it's 1, 2, 4, 9. The rate at which it grows is very big. And it's the same as when it decays. It's going to decay the same way. The growth is going to be very fast. As the value of x is increasing, the value of y increases exponentially. So that's what you have. And as it increases on the negative side, it's approaching 0, but it never touches 0. Okay, so that is not the case because I touched 0. So you will have something like that. So that will be your exponent. So that is a representation of an exponential function. The example we did, y is equal to x, was very basic. So an exponential function will be given by y is equal to a times b to the x, right? So we will get to see the effect of a and the effect of b on the exponential function. But that is not finished. You will get to see that there are restrictions that will be given. For example, you will see that b should be greater than 0 and b can never be equal to 1, right? So that those are the restrictions that are given with the exponential function. I will show you a demonstration of how we get to come with these restrictions when we talk about exponential functions. So we will start with, okay, let me do it like this. What happens when b is greater than 0 but less than 1? Because we have that restriction of 1. And then what happens when b is greater than 1? What happens when b is equal to 0? And what happens when b is equal to 1? Because we want to see why can't we have b is equal to 1, and also why is b greater than 0. And we will also see what happens when b is less than 0, because you see that restriction is saying b has to be positive. Now we want to see why is it not an exponential when b is less than 0, and when b is equal to 0, and when b is equal to 1. Okay, so we will start with 1 times 2 to the power x. So the 1 is the value of a and 2 is the value of b. As you can see, that is a value of a and that is a value of b. But we are starting with the basic function. Therefore, the a value is equal to 1. So let's see what happens. We said we want to see what happens when b is greater than 0 but less than 1. So that means it's a fraction because it's between 0 and 1. So let's see what happens when that is the case. Okay, so we don't want a negative value. So what happens when it's greater than 0 but less than 1? So we move like that. You can see what happens as we go closer to 1. It's getting wider and wider and wider, right? So we can see even the way it grows, that it grows on the negative side when that is a fraction, because you want to keep this shape so that when you're given a question, immediately you already know. Let's say they say calculate a value of b and they have given you a graph looking like this. From this, you should already know that, oh, okay, I already know that if b is a fraction that is between 0 and 1, I know that it grows on the negative side of x like this. And the more it gets close to 1, it's getting wider and wider. That is, it opens up. Then now we have seen that. Let's move on. What happens when b is greater than 1? So let's go to b is greater than 1. We'll come back to b is equal to 1. So you see what happens when b is greater than 1. It becomes, as it grows, it becomes steeper and steeper and steeper and steeper as well. And then as it goes close to 1, it's becoming wider, right? But note that when it's greater than 1, when it's greater than 1, it grows exponentially on your right hand side, and that is on the positive x-axis. Now we're on b is equal to 1. Look at this. As it goes close to 1, you just have y is equal to 1, right? Because when you have a base of 1, it doesn't matter if it's to the power 1,000, million, it will always be 1. But look at that, when b is equal to 1, that is not an exponential function. It's just a straight line. So therefore, b cannot be equal to 1 because you are not going to get an exponential function. So now we have seen what happens when b is greater than 1 and when it's a fraction and when it's equal to 1. Now we want to see what happens when b is equal to 0. So that is b equal to 0. You just get 0, like there it is. You just get 0, positive 0. So that is not an exponential function as well. So that is eliminated. b is not equal to 0. What happens when b is less than 0? I will show you that later after we have written this down. So let's go back to the notes. What did we do? We did b is greater than 0 and less than 1. So what did we do? We did b greater than 0 and less than 1. Mind you that a is equal to 1. That is, a is positive in this case. We're not talking about a yet. So what we've seen is that, okay, I have my exponential function there, and we see that, oh, when b is greater than 0 but less than 1, it grows this way. But note that it always cuts there. There's that value we should not forget. Don't mind my drawing. So that is b is greater than 0 but less than 1. And we saw that when b is greater than 1, that's the exponential function. And that's still the same point, 0 and 1. And then what happens when b is equal to 1? We saw that we will always have 1. And this is not an exponential function. Therefore, this is out. And then when b is equal to 0, we'll always have 0, and 0 is always positive. So we'll have a function on 0, and this is not an exponential function. So we now understand. For example, I'm doing this so that you know. For example, they give you a graph at school, and they give you, let's say, y is equal to 1 over 4x. By just looking at that graph, you already know that, oh, okay, without me even doing the points, I already know that, okay, this is between 0 and 1. I already know it's going to grow like that. And then it's a matter of where the points are. But you already know the shape of the graph by looking at it, because you understand the effect of the parameters. That is, in this case, the effect of b. So let's get to see what happens when b is less than 0. I will demonstrate that here. So what happens when b is less than 0? So that means, okay, y is equal to negative 2 to the power x. This negative here is not part of a. As you can see, I've put it inside the brackets, meaning it's not like negative 1 times 2. It's negative 2 all to the power of x. That is a difference. So now what happens? So what happens when x is equal to 0? So when x is equal to 0, any number to the power 0 is 1, right? So what happens when x is 1? So you will have 1, then you will have y is equal to minus 2 to the power 1, and then you have minus 2. What happens when x is equal to 2? You have y is equal to negative 2 all to the power 2, which is going to be 4. So that's positive. And when it's 3, y is equal to negative 2 to the power 3. So that will be 9, negative 9. And then when it's 4, it's going to be positive. And then when it's odd, it's negative. Look at what's going on. If we were to draw this, we will get something positive, negative, positive, negative. So when it's 0, when x is 0, we have 1. When x is 1, we have negative 2. And then when this is 1, this is 2, this is 3. Then when x is 2, we have 4. When y is 3, we have 9. When x is 4 is 16. and then and so on. You can see that. So we will get something that is sinusoidal like that. Is that an exponential function? No. Therefore, we already eliminate that b cannot be less than 0. So we go back and see that this also falls out. And therefore, we understand that with an exponential function, b has to be greater than 0 and b can never be equal to 1. Now we understand the effects of b. What happens now when the value of a changes? Look at this. Now that we understand that b has to be greater than 0 and b cannot be equal to 1, we will not be evaluating this because these are not exponential functions. So we will only be working with this. So let's go back to the graph and see what happens when when a now is becoming bigger and when b is becoming is part of these two. So we have, let's start with b is equal to 2x. Okay, so that's that. And then the value of a in this case is 1. What happens when the value of a becomes bigger? Remember, we have seen the effect of a on a quadratic function. That as the value of a becomes increases, the curve gets steeper. So let's see if that's the case with the exponential function. So as the value of a increases, you see it's becoming steeper and steeper and steeper, right? But it hasn't reflected. It's still, the growth is still on the positive x-axis. So we understand that as the value of a increases, the graph becomes steeper. So what happens when now the value of a increases on the negative side? Mind you, we're still on b equal to 2. That is, b is still greater than 1. So what happens is that, you see, immediately I go negative. The graph reflects. We were talking about b is equal to 1 because we had y is equal to 2x, right? So here you notice that the graph is a mirror image of this graph, but it's just reflected by the x-axis. So now it's on the y-axis. So that is when a is less than 0. And then this is when a is greater than 0. So let's see here what happens now when we have a value. Let's say now we will do 1/2 because it's greater than 0 but less than 1. What happens when a changes? So now we have half, which is 0.5. So that is the case. And then we want to see what happens when a is getting bigger. You see, when a is getting bigger, the graph is getting steeper. And when a is getting smaller, the graph is getting wider. But now note that immediately when a is equal to 0, the whole graph will be 0. And now when it becomes negative, you see, we also get a reflection. So it's the same case here. You still get the same graph, but it's reflected by the x-axis. So that is your graph when a becomes when it's less than 0 and when it's greater than 0. So those shapes should just get you started. That is, by the look of a question, you already know, which side is it, which you know what I mean. Like, you should already understand where you're gonna draw your graph, and if you have to calculate any parameter, you know what you are expecting, so that you can already mark yourself, that is, if this question is right or wrong. And that's it for this lesson. Thank you.